Welcome back, ladies and gentlemen. We are now on day 2 of chapter 1. So by the end of this lesson, you will be able to calculate and display marginal distribution of a categorical variable from a two-way table, calculate and display the conditional distribution of a categorical variable for a particular value of the other categorical variable in a two-way table, and describe the association between two categorical variables by comparing appropriate conditional distributions. And once more, this is the book assignment that we would complete at the end of this lesson. All right, so we're looking at two-way tables, marginal distributions, relationships between categorical variables, and conditional distributions. Let's dive right in. So day 2, 1.1 day 2, analyzing categorical data. And you can find this information on pages 13 to 22 in our textbook. So what is a two-way table? A two-way table is a table of counts that summarizes data on the relationship between two categorical variables for some group of individuals. Now, a marginal relative frequency gives the percent or proportion. Remember, proportion is us dividing out our fraction, and then if we multiply by 100, that's what gives us percent. All right, so marginal relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable. So just one categorical variable. Now, I forgot to write down that this right here isn't actually a blank for you to fill in. This is how we write the context of a marginal relative frequency. The proportion of all, right, you can fill in the blank for whoever you're talking to. So the proportion of all who are, and then the categorical variable we're referring to. So marginal relative frequencies are calculated using the totals in the margins of the two-way table. Now, what is a joint relative frequency? Right? For our definition, a joint relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. Now, these are often written as the proportion of all who are context of the first variable and context of the second variable for the values that they're taking. All right, so we identify the proportion of all who are value of first variable and value of second variable. Now, I do have a typo here. I forgot to type in the T for joint, so this isn't joined, this is joint. So in the body, a joint is where two bones come together. In a two-way table, a joint frequency is shown where a row and a column come together. Right? Now, what is conditional relative frequency? A conditional relative frequency gives the percent or proportion of individuals that have a specific value of one variable among individuals who share the same value of another categorical variable. The value that they share of the other categorical variable is the condition. So this is often written as the proportion of blanks who are blank. So the proportion of, identify the value of the categorical variable that these people have in common to identify who they are, and then which portion of that distribution you actually want to look at based on that category. All right, let's take a look at some of these. All right, so for our example, researchers surveyed a random sample of 2009 U.S. households in June of 2020, roughly 3 months after COVID lockdowns began. Researchers asked whether anyone in the household had an injury that occurred at home or ingested something that could make them sick while at home during the previous 3 months. They also classified the households as urban, suburban, or rural. And here are the results. So over here we have the type of household: urban, suburban, rural. Urban would be like inner city, suburban would be in the surrounding towns near a city, rural, out in the country. All right, so they classified both types of injury, both injury and ingestion. Injury or ingestion, but not both, because both was already written up here, and then neither one. And then we have totals in the margins. All right, so when I was referring to numbers in the margins, I was referring to these outer edges where we have the total of the columns and the totals of the rows going across. And then down here we have the total of all of the values. All right, so for letter A, what proportion of the households in the sample had both types of incident? Now, this would be a marginal distribution because we're looking at what proportion of households in general. We're not referring to type of household, we're not referring to type of incident, households in general. So households in the sample had both types of incident. So we want to know out of the 2009 households surveyed, how many had both types. Well, go all the way out to the margin here because we don't want to just do urban, suburban, or rural. We want all of the ones who had both. There are 269 households out of the 2009 that were surveyed. Right? So that's why my fraction is 269 divided by 2009. Now, if you go ahead and complete the division for this. All right, so I'm going to pull up my calculator. If I do 269 divided by 2009, that's going to give me 0.133897, so on. Now, I'm going to take this out to 4 decimal places. If I wanted to turn this into a percent, I would probably want that percent out to 2 decimal places, and multiplying by 100 would move my decimal point 2 places to the right. So this is actually 13.39 approximately percent, but we want the proportion, not the percent. You can either leave it as the fraction, or you could write this as 0.1339. You could also truncate it and leave it as 0.1338. Just be consistent with whatever you do. Right. Now for letter B, what proportion of households in the sample were rural and had both types of incident? So now we're looking at combined type. And remember, when we're writing it as the proportion of all who are blank and blank, that's when we're dealing with joint. So we're taking a look at the proportion of individuals who have a specific value for one categorical variable and for another. And we're still looking out of all of the households. So our denominator is still that 2009. But when you look at both, so both types of incidents across this way, and then rural, this 18 right here is when you have the row for both and the column for rural intersecting each other. Right? That's where they join each other. So our joint probability would be 18 over 2009. Now again, you can turn this into a decimal if you wish. 18 divided by 2000 is about 0.00895. Right? Now, if you have something like this and you're rounding, this 5 would round the 9 up to a 10, which would make this 0.0090. Right? If you're rounding a 9 up, it actually carries over into the next one. You could also just truncate it at 0.0089. But again, you need to be consistent. Because I rounded here, I went ahead and rounded here. Now you don't actually have to write out the decimal, the fraction would be enough, and I'm just going to leave it as the fraction from here on out. Now for letter C, what proportion of the rural households in the sample had both types of incident? Now I'm not taking proportion of households, I'm taking proportion of rural households. This is how we know that we have a conditional distribution, or a conditional relative frequency, and in particular, the condition is the rural households. I only want to take the proportion of rural households, which means I need to look at just the total number of rural households and then how many of them had both types of incident. So 18 had both types of incident out of 384 rural households. That's when my denominator has changed, but my numerator stayed the same. Now for letter D, what proportion of the households in the sample had both types of incident, were rural? So proportion of households in the sample with both types of incidents. This isn't just talking about households. With these others, we're looking at proportion of households in the sample had, proportion of households in the sample were. This one says proportion of the households in the sample with. We're identifying a value that these households have that we're taking the proportion out of. So this is again going to be conditional. And the condition is that they had both types of incident. So I'm looking at the total number of households with both types of incident. That means that the denominator of my proportion is going to be 269. And then when we're looking at out of those 269, how many of them were rural, we're back to that 18. This is how you know you're supposed to have each of those denominators. Let's move on to the next page. Now, what does it mean for two variables to have an association? We're looking at these conditional relative frequencies to try to determine association. So there is an association between two variables if knowing the value of one variable helps us predict the value of another variable. Now, that means that there's a predictable relationship between how the two variables change. So if knowing the value of one variable does not help us predict the value of the other, then there is no association between the variables, meaning that they're independent. Now, how can you see an association between two categorical variables? And what are the three graph choices? So you could make a side-by-side bar graph, a segmented bar graph, or a mosaic plot, right, showing the distribution of the response variable for each category of the explanatory variable, right, which means you're basically creating conditional distributions. So a side-by-side bar graph displays the distribution of a categorical variable for each value of another categorical variable. The bars are grouped together based on the values of one of the categorical variables and placed side by side. A segmented bar graph displays the distribution of a categorical variable as segments of a rectangle, and the area of each segment is proportional to the percent of individuals in the corresponding category. A mosaic plot is a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. Now, if the height of the bars are still related to the proportion or the percent of individuals within the response variable, the width being related to the number of individuals in the categories that we're splitting up along for our conditions means that the area within a mosaic plot actually shows the joint frequencies. Right, so let's take a look at example 2. Right, Yellowstone National Park staff surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether he or she belonged to an environmental club like the Sierra Club. Respondents were also asked whether they owned, rented, or had never used a snowmobile. And here is the two-way table summarizing the results. Keep in mind, this is a summary, not the raw data. So when we take a look at snowmobile use, we have never used, renter, owner. And then environmental club, we have no, yes. In the margins, we have our totals. So the figure below compares the distributions of snowmobile use for Yellowstone National Park visitors who are environmental club members and those who are not environmental club members. So we're using environmental club as our category or as our condition. And then we're looking at the distribution of snowmobile use based on that. All right, so we have a side-by-side bar graph example right here. So you can see that the bars are literally side by side. And we have the percent of people who did not have environmental club membership who own, rent, and then never own or never used snowmobiles at the park. And then we have those who do have environmental membership with own, rent, and then never used. You can see what part out of the whole the different values of snowmobile use take up within the different categories of environmental club membership. And then over here, you can see that they actually survey quite a bit more people who were not part of the environmental club compared to those who were, right? Which is why this bar is so much wider. Now, this is not deceptive because this is intended to reflect how many individuals, basically the proportion of individuals with environmental club membership versus not, as well as the distribution of their snowmobile ownership. So in a mosaic plot, the difference in the width of the bars actually serves a purpose, as opposed to just being, haphazard. All right, so segmented bar graph can be obtained by stacking the bars in the side-by-side bar graph for each of the two environmental club membership categories. So because these were percents, you can literally put this one on top of here, and then this one on top of that, and you get this one on top of here, and then this one on top of here. The totals will both be 100%. The bar widths in the mosaic plot are proportional to the number of surveyed respondents who are the 305 and who are not the 1221 environmental club members. So mosaic plot provides more information than the other two types of bar graphs because it shows relative group size. Okay, let's go to our last page. And in this one, we're kind of continuing example 1. Now, we need to display the relationship between the type of household and type of incident using a mosaic plot. And then based on the graph, is there an association between type of household and type of incident? And we need to explain our answer. So what I did is I went through and I determined what proportion of respondents were from urban households, suburban households, and the rural households. Suburban households had the most with, I believe it was just under half. And then urban households were next, and then rural. And I separated this up into the proportion of households of each type. And then the heights of my bars were based on the proportion for both injury or ingestion, and then neither. All right, so there does appear to be an association between the type of household and type of incident. Urban households had the highest percent of both types of incident, 26% versus 8%. And 5% respectively, compared to the suburban and urban households. So 8% went with the suburban, 5% went with the urban, while the urban households had, I believe that was supposed to say rural. And every now and then I make a mistake with my writing and have to correct things. There we go. Rural households. All right, so the 8% was suburban, 5% was rural, which makes sense based on the shading that we have up here. Both was completely shaded. So urban was the highest, suburban next, rural the least. Suburban households had a higher percent of injury or ingestion, but not both, 21% versus 12% and 14% compared to the urban and suburban households respectively. Ooh, urban and, I keep making a mistake with that. My bad, ladies and gentlemen. Let me adjust this. So for that one, the 21% of injury and ingestion, highest was actually rural. Well then. And then 12% and 14% respectively for urban and suburban. Yes, because this was narrower than this one. Apologies. Sometimes even I make mistakes. It's always good to go back and to reread your response to make sure that you have everything that you should and that it's actually correct. Even teachers make mistakes. Right, now, if there were no association between type of household and type of incident, how would the mosaic plot differ? Well, if there were no association, the segments of the bars would have equal heights. Now, if there is an association between two variables, should you conclude that changes in one variable will cause changes in the other variable? Not necessarily. All right. Association does not imply causation. All right. So as an example, wearing a bikini helps prevent getting gray hairs. So I've shown a segmented bar chart here, one for bikini wearers with 1% gray hair and one for non-bikini wearers with 25% gray hair. Does wearing a bikini cause you not to get gray hair? I don't think so. That is not logical. All right, so just because there's an association does not mean that's cause and effect. It just means that there seems to be some sort of relationship there. Maybe people without the gray hair, also feel better about their bodies. Who knows? All right, so this is the book assignment that you should attempt after this lesson, and I will see you in class.